Welcome. I am Rakesh Doddamani, Senior Competency Head and AI Ambassador at ALTEN India. In my role, I work at the intersection of engineering data, decision making, helping teams move beyond AI experimentation to measurable business and delivery outcomes. I'll be moderating today's discussion and ensuring we stay grounded in real engineering impact. So with this, let me quickly set the context. For that, I have a quick question. Hands on heart, would you feel safer today in a car driven entirely by AI or with a human driver on a really bad day? Now, let me raise the stakes a bit. Would you fly in a pilotless aircraft? And let that sink in. With that, across aerospace and automotive industries, we are operating in a world of constant disruption, uncertain supply chains, regulatory pressure, shrinking timelines, and exploding system complexity. And this is what we call as VUCA. And for those of you who don't know about VUCA, VUCA stands for volatility, uncertainty, complexity, and ambiguity, a framework describing the rapid, unpredictable changes and challenges in the modern business and global environment. Now, the question is not whether we use AI anymore. The real question is, how do we move from VUCA to rapid without losing trust, safety, or engineering integrity? It's about how AI is being responsibly embedded into real engineering workflows. So decisions get faster, systems get stronger, and outcomes get predictable. To explore this, we have two leaders I would like to welcome. Dr. Jayanta Kumar Ray, a globally recognized technology leader, top 50 GPS leader worldwide, Indian Institute of Science gold medalist, and PhD from University of Calgary. If anyone knows how to engineer clarity in complex safety critical systems, it's Dr. Ray. And along with him, we have PRAMOD NANJUNDASWAMY, Vice President, Delivery and Technical Direction, with 25 plus years of global automotive and mobility leadership experience. And Pramod doesn't just talk AI transformation, he executes it at scale. With this brief introduction, I encourage everyone to stay engaged, drop questions in the chat, and participate actively. So by the end of this webinar, if you can walk away with one clear idea or where to trust AI, where to challenge it, and where to start, then we have done our job. So with this, we'll begin by grounding ourselves in aerospace, moving to automotive, then bring both together through regulation, limits, and finally a rapid fire round. I'll be purposeful in switching between speakers, not to rush, but to bring contrast, clarity. So let's start with Jayanta. So Jayanta, from design through to operations, how is AI transforming the aerospace industry today? And looking ahead, where do you see AI creating the most tangible impact over the next 3 to 5 years?
Thanks, Rakesh. Thanks for the introduction. I hope you all can hear me.
Yes.
Okay, thank you. As you know, we have been, in the aerospace industry, it's a very document-driven, it's a very regulatory space. And from there, we are moving towards data-driven, industry. AI in aerospace is rapidly catching up with other industries, particularly automotive, because automotive, the acceptance of AI is much more than aerospace today. But aerospace is also catching up. I see that there is about 30 billion industry of aerospace of AI, and it is going at a rate of almost 30% CAGR. So there is a lot of opportunities. There is a lot of acceptance of AI in aerospace. Essentially, AI is actually applicable for aerospace in two aspects. One is the aviation part of it, and the other is the the aerospace part of it. Now, when you look at the aviation part of it, AI is getting more and more used in air traffic controlling. AI is getting used in supply chain management. AI is getting used in cyber security and protection of the aircraft from cyber attacks. AI is getting used in pilotless car. AI is getting used in unmanned aerial vehicles. So these are the areas where AI already has penetrated and getting more and more prevalent. If you look at the aerospace, there we talk about actually building an aircraft or building a avionics system. So in this case, AI again is getting into quite a bit. For example, you can use AI for doing your design. You can use your mechanical activities, mechanical design of the aircraft. AI can be used, and AI has got a lot of use cases. For example, AI accelerators can be used for shrinking the timeline for development of the software, development of the hardware. So, for example, you can build a circuit using AI based on the past, past history, past examples of how it was done. With this taking as an input, as a learning point, you can actually use AI and design the new circuit just like that. And of course, AI is used for code generation, verification, validation, testing, and so on. AI is also used extensively for some of the other development activities like digital twin for testing a electric engine. So over a period of time, AI is now becoming more and more prevalent, and the regulatory bodies are also accepting it to a great extent. So I think coming years, you will have more and more AI coming in our day-to-day life, and we'll be using every time we fly in the airspace.
Now, I agree with you on the in the safety critical context, right? So aerospace is inherently safety critical and has long certification cycles and zero tolerance for failure. So how does AI adoption in aerospace differ from typical enterprise or consumer AI use cases? Could you please throw some light on that?
Typically, if you see the consumer AI or enterprise AI, typically, the way AI works is you have the models, you have the machine learning models, which takes inputs and gives you an output. It's very probabilistic. As you keep on adding more and more data, you keep getting more and more refinement of the model, and at the end, what you get, it is not so deterministic. In contrary, what we need in AI, in the case of aerospace, has to be deterministic. For a given set of input, you should always get the same output. Unless you do that, you cannot use AI in aerospace. So the conventional sense, the normal AI models, or the normal way the AI works in consumer and enterprise applications cannot be used directly in aerospace. Now, also, if you see the consumer AI, most of it is actually sits in cloud, and in case of enterprise AI, it works along with the ERPs and CRMs. Whereas in the case of AI in aerospace, it has to work in the embedded platform. So that is a significant difference with respect to the standard AI. Plus, the aerospace AI, you do not get a lot of data like which you get from the consumer AI. You get tons of millions of data, which you do not get in case of aerospace AI. So there is a limitation of the amount of data that you can get, and you have to make do with the amount of data that you can get. So, and as you know, in case of aerospace, say software development, you have to comply with a lot of regulatory requirement. You have to, if it is a design assurance level A, you have to have a failure rate of not more than 1 in 1 billion. So for that kind of a reliability, the entire thing cannot be automated, or AI cannot be used for the entire thing. You always need to have a human in the loop. You need to have ensure that the last decision is taken by human, not by AI. So there is a significant difference of how AI can be used in the aerospace parlance in comparison with the in the other applications.
So we have just heard how AI plays out in a domain that optimizes for certainty before action. Let's now shift gears to automotive, where scale, speed, and software velocity change the equation. So Pramod, how is AI reshaping the automotive industry today across design, manufacturing, and mobility?
Thanks, Rakesh, and happy to be here and conversing with you and Jayanta. and probably bringing two contrasting views on automotive as well as aerospace. Coming to the question that you asked, so automotive at least has been at the forefront of usage of AI, if you ask me, from last decade itself, past 15 to 20 years. And it is getting more and more accelerated. So we already have autonomous vehicles in a way running in at least specific controlled cities like Austin and San Francisco, and some of the advanced driver assistance system features, whether it is emergency braking, lane departure warning, or lane control. So there are a lot of these specific use case driven applications which are already there in majority of the vehicles, not only globally but even in India. So that is a clear area, autonomous driving and driver assistance system related features. Now, other major area where AI gets used is hyper personalization. That means based on a person's mood or his specific day or his habits, how does a car react or behave? How do we make the mood lighting or the music gets played? So this kind of hyper personalization gets also done using AI, and that's where it gets heavily employed. And the other key thing is also diagnostics and predictive maintenance of the vehicle itself, right? So when we know particular wear and tear is happening based on the sensors and the data that is coming through, can we predict, and based on the prediction, can we have the part ready and even suggest which service center the car can go to with that part availability by what time, so that the whatever down the part the car doesn't get break, car doesn't become dysfunctional in a way. So this kind of predictive maintenance is another area where we deploy AI. That's more on the vehicle application standpoint. On the manufacturing side as well, whether it is right from physical layout optimization, because everything gets played now in a virtual world. So that means we do a digital twin of the entire floor or the building itself, and then do permutation combination of layouts, manufacturing layouts, which one gets more optimized, process layout. So that way efficiency and quality control is another area where AI gets used. And the other key thing is also predictive maintenance, again, of the factory itself, where we prevent the machines from going down, wear and tear. Robotics and computer vision based systems is another area in manufacturing. So that way, whether it's vehicle or manufacturing, and other key aspect is of the development or the design of the vehicle itself, right? So within that, whether it's AI-led simulation design, where AI generates the remote edge cases or environmental conditions which cannot be easily simulated in a regular non-AI-led simulations. So we use a lot of AI there, and also in validation, verification, like right from, if you just give a requirement, entire test script, including automated test cases gets generated. So we have such systems, and of course auto-generated code, which Jayanta talked about, is also there in automotive world. So that's why entire HDLC, SDLC life cycle or product life cycle is very well uses AI. And the other key aspect is aftermarket services as well, right? So technical publication, level 0, level 1 customer support, chatbot based support. So these are the critical areas that AI is already being heavily deployed. Yeah.
Right. So you know, we know that automotive systems today operate at massive scale and also are safety critical as well. You know, how does this scale, you know, change the way AI is validated and deployed compared to other industries? Some of it you might have already answered, but I'll just ask you again. So how, is it impacting the scale?
Yes, scale, that's where a majority of the companies are now going for more platform approach because of the scale, where the volume is higher. And that way, if you have a reusable platform approach, whether it is a vehicle platform or a AI-led simulation platform, or a development, software development, which is a more platform oriented approach. So that's where the critical platform led development is happening. and that's where extensive, because the scale is bigger and impact would be catastrophic if something goes wrong. There is more emphasis on regulatory compliance and extensive validation at scale, right? And then insisting on explainability, interpretability, because whenever any accident happens, what caused the accident should be able to, the OEM should be able to explain it to the regulatory people or the anyway corresponding stakeholders. So that's why interpretability, traceability, and explainability become a key aspect. Considering all this, other key aspect also is a fail-safe design, right? So that's what gets emphasized more in a automotive world. So while AI is used, we give in a way priority for the compliance, for the safety, and the in end consumer comfort in a way as a key aspect whenever AI gets used. Yeah.
Thanks. So coming back to aerospace, specifically on regulation and limits, Jayanta, or certifications. So how are regulatory bodies like EASA, FAA, DGCA viewing AI today? Do you see regulators actively enabling AI adoption, or is regulation still a major bottleneck?
Yeah, I mean, because of the safety aspect of it, aviation community, particularly the regulatory authority, did not embrace AI like the way it is embraced by common public, because here the safety is of paramount importance. The European Regulatory Authority, which is EASA, and the Federal Aviation Administration of United States, so they have shifted from a posture of cautious observation to actively enabling AI adoption. And they are doing this, ensuring that there is no compromise on the safety and making the certification process meticulous and very, very strict. So basically, what today FAA and EASA are doing, and even for that matter, even CEMILAC, which is the Indian Regulatory Authority, they are coming out with the guidelines and rules of how AI can be used in not very high safety critical applications. As you know, we have a 5 levels of safety critical systems, like design assurance level A, B, C, D, and E. A being the highest and E being the lowest. So today, in particularly say in case of CEMILAC, they are considering to use the up to design assurance level C use of AI. So that means it is not so safety critical environment, but still it is the regulatory authorities purview as to how its certification can happen. Towards that, see, even if you want to certify, you also need experts who can actually evaluate such data package or such system, even though it is a design assurance level C. So there are industry bodies, there are authorities who are coming up with a training material and making the auditors as to how to certify AI in aviation. So there is a process which has started and which has begun now. The AI, the FAA, EASA, CEMILAC, all of them are trying to adapt, but in a cautious way, not so rapidly in case of automotive or other applications, but in a cautious and gradual way, where they actually are training their officers, their personnel to make them enable to understand the safety risk it could be if they if there is a miss or a slip. And after those training, after they are able to provide them enough guidance and training of how to certify the products or the services using still complying with all the guidelines to the level of level C, right, they will start allowing people to certify in those those products as per up to level C.
Understood. So again, moving back to automotive, Pramod. So from a regulatory standpoint, is AI in automotive being treated more as an opportunity to innovate faster, or as a risk demanding tighter control?
So at least it is seeing both, and that way there are no specific AI driven regulations per se, but there are regulations which kind of take care of risk that AI brings to the table. and some of that gets handled through the functional safety standards like ISO 26262, which mandates for any safety critical device what are the, whether right from development framework to what are the fail safe design technologies we use, how the whole thing gets validated, and how so that way ISO 26262 takes care of the functional safety aspect, while some of the cyber security and software update related compliances are taken care by UNECE R155 and R156 regulations. Similarly, we have GDPR, those kind of data protection acts, which automatically takes care of some of the user data protection whenever any of the data gets used for validation or even for processing standpoint. Similarly, we have S4TIF, which is like safety of the intended functionality, which is specific to ADAS functionalities or driverless cars kind of systems. And only probably the AI specific act that more or less comes into picture is the European Union AI Act. So together these kind of puts up a framework in place which automatically, not automatically, at least put some sort of control over usage of AI, particularly when it comes to deployment in a vehicle and impacting end user standpoint. So that way, at least there is a good system in place to address the safety and security part, data security part, but that itself is not also stopping companies from using it for innovation purposes, which is anyway happening in the simulations or automations or development and validation cycles, which I earlier spoke about, including the functionalities of a car. Yeah.
Understood. So let's bring this home to ALTEN's perspective. So Jayanta, how is ALTEN approaching AI in aerospace engineering? Could you share a few examples where AI is already adding value or delivering measurable value?
Yeah, actually, I would say the ALTEN is taking leadership in AI adoption in the area of aerospace. In fact, several years back, we started looking at AI, how it can be used to give a measurable benefit. For example, in the airspace, when the pilot sees a lots of aircraft, he or she has to make a decision as to which of the aircraft would actually potentially be a threat to conflict with your path. So based on the information available, the position of those aircraft with respect to its own aircraft, and the velocity and acceleration of those aircraft with respect to your aircraft, it has to decide that which of those could be a threat and then communicate with them to ensure that there is a safe path. So you need for spacing, of the aircraft in the sky in real time, the AI has to be used, and we have worked on those with the US customer, some time back. So this is the kind of in a way like one of the early projects where we had taken AI into the aerospace. In the last several years, we are working on programs where we collect a lot of data for drone analytics. We collect a lot of data from the drone to understand what is the kind of preventive maintenance that is required. Looking at the batteries, looking at the the structure, looking at a lot of parameters, health parameters of the drone while it is flying, as to when we have to do the maintenance of different parts of the drone. We are also using AI for preventive maintenance as well as for quality check. Recently we have worked on a program where AI is used for quality check, the final quality check. AI is also used, for example, vehicle aircraft, detection, identification, and tracking. So we need that. You can use the radar for detection, and you know where the aircraft is, other aircraft is. But if you want to actually identify what the aircraft is, and you want to actually track the aircraft, you need AI. So here you need to have a AI which is certifiable, because it has to be sitting in an aircraft and then trying to do all this job. So you need a different type of AI, than what conventional AI, what you see for consumer and other things. So we have been using AI in a quite substantive way in ALTEN for the last, I would say, 5 to 10 years.
Right. So, Pramod, similarly for automotive, where is ALTEN creating, a clear differentiation for its clients through AI, and how does it translate into, again, real delivery or business outcomes?
Yeah, so one is AI in itself may not mean anything unless we bring a domain and a system angle to it, right? So Alten having automotive domain experts and with the knowledge of deploying AI in the specific industry at scale globally as well brings in the clear differentiation, because it's not just the AI tools or techniques which anyway is there out there, but how does that gets deployed in an automotive world. And again, coming to how does it makes a business sense, right? Showing the ROI part of deploying the AI. That's where we bring a clear differentiation. And sometimes it's not also about doing a full drastic transformation. It is those small things in the day-to-day work that we do, which can be easily automated using AI with small changes, if not a big drastic change, because we see both sides of kind of customers. Some people who are kind of little bit hesitant to deploy it on a large scale, but still want to deploy it where the development, the end consumer getting benefited. And we specifically bring those kind of use cases looking at customer convenience level, make them part of the development story, show them what it how it benefits them, and then take them along and help them to deploy it in those use cases. In some cases, there are customers who want full transformation, right? The requirement could be as simple as I give the requirement spec, and I need the complete simulation model, including the automated code automatically generated, validated code in a way. So then that sort of a complete AI-led development process transformation is also there, where we have helped our customers. So that way we work with all kinds of customers who are just there in the initial level of adaptation and not open to deploy it at scale. But there are customers who are looking to deploy it at scale. That's mainly our customer standpoint. But from a vehicle angle, again, whether it is deploying a simulation, deploying a perception system, which platform to be used, what algorithms. So we help customers with those kind of algorithm development, platform development for perception system. Similarly for hyper personalization, whether it is audio or playing a mood based audio or mood based lighting. As you know, Alten is as expertise not only in hardware, software, semiconductors, as well as complete product lifecycle development and aftermarket service support. So we tend to work with our customers where all AI can be deployed, proactively work with them to ensure that gets addressed in a way. Yeah.
So thank you both. So up to now, I think we have been thoughtful and structured. Now we are going to be a bit faster, more instinctive, and slightly uncomfortable, maybe in a good way. So Jayanta and Pramod, this is where instincts begin, no filters. This is rapid fire. So the rules are simple. One sentence, gut reaction. I'll cut you off with love if you elongate. No explanations allowed, even if you are tempted. So ready?
Sure.
Yeah.
Yes.
Okay. So I'll be switching between you both to make it interesting. So Jayanta, pilotless aircraft. Would you board it tomorrow? Yes or no?
Yes, it's certified.
Okay. AI as a co-pilot or an autopilot. Pick one.
Autopilot certified.
Okay. So Pramod, so fully driverless car. Would you nap in it? Yes or no?
No. Yeah.
Okay.
May sit in it, but definitely not nap.
AI as your co-driver or backseat driver. Choose carefully.
Co-driver.
Okay. Moving to Jayanta, one word, the future of aerospace with AI.
Inevitable.
Inevitable. That's a good one. So, Jayanta, again, would you trust AI more than a human engineer on a bad Monday?
Not today, maybe in the future.
Okay. Moving to Pramod. So, this is an interesting one. Bangalore traffic or debugging a release at midnight? What's more stressful?
Bangalore traffic, because the other one I enjoy. It's not a stress. Yeah.
Okay. So, again, Pramod, biggest AI value today, faster development, better quality, or lower cost?
Faster development.
So, moving to Jayanta, what breaks first in real programs, data, processes, or egos?
Ego.
Good one. Again, Jayanta, if an AI model says 99% confident, what is your first question?
Not good enough. We need 99.9999999% in aerospace.
Okay. Pramod, flying cars in 10 years, real or hype?
Real. I would say the eVTOLs already can be easily converted to a car.
Again, for you, one word, the future of automotive with AI.
Oh, it's for me?
Yes, Pramod, for you. In automotive with AI, the future of automotive with AI, one word.
Interesting.
Okay. Okay, so that's the end of rapid fire, and I think it was refreshingly honest. At least for me, I think everyone would agree with me. So, what stands out is this, same AI foundations, very different realities, but in both industries, trust and decisions matter, right? More than novelty. So, with this, I would like to, we'd like to spend some time on Q&A. So, please post your questions and we'll be happy to answer if you have any. I'm looking at the questions. I think you can put it in the chat here because I don't see the Q&A enabled, but yeah, you can put it in the chat. We'll be happy to take. Or do I see the chat is enabled? Q&A.
Rakesh, you can go ahead with the next question. So, in the meanwhile, if any question comes, we can take it up.
Yeah, I think, no, what I want to say is what we heard today is not, AI versus humans. It's AI with accountability. The future belongs to engineers who know when to accelerate and when to take control. So I think, that's my view and that's my takeaway. And I would let, Jayanta and Pramod to summarize, or if you want to add a few words.
Yeah, actually, I was reading a news yesterday that, AI coding agent in 9 seconds wiped off the entire, the code and the backup startup in the USA.
Yeah.
So unless it is done responsibly, the AI could be devastating.
Yeah.
So you, particularly in the safety critical application, safety critical environment, a bad weather may actually be like a threat, and then you may take a decision which is very detrimental and could be catastrophic. So while it is important to use AI to shorten the development life cycle, to improve the productivity, efficiency, but at the end, I think, till such time when we have a very, very predictable result, AI cannot be fully trusted, and we need to have human intervention for the last, level of decision, because highly safety critical thing cannot be left to only AI, at least to the level of maturity that we have today. We need to have, the human in the loop to ensure that for safety critical applications for both aerospace and automotive, human, has to be there. Human has to take the final decision. And I think, unlike the consumer and probably enterprise AI, where the stakes are not that high, here we talk about real life, people losing life, people having in a very situation where it is very, very dangerous for them. So in such situations, we need to be very responsible as to how we use AI, and we have to take ownership of what we do.
We have a question here by Rajesh. So Gen AI or digital twin, which one will be the priority in both the industry? So who'd like to take it?
Yeah, so I'll start off. For automotive, at least digital twin is the starting point, right? You open endless world of opportunities if you have a digital twin of a car or a digital twin of a factory, and then you can of course bring Gen AI on top, and then in a way reap benefits, if I have to say like that. But everything starts more or less with having a digital twin, and that's where I would at least put my first bet on. Just to add to that, Gen AI is catching up and is also becoming more and more fruitful tool to have, but still as of now digital twin. Yeah.
Okay, thanks.
Yeah, I also agree with the PRAMOD. I think digital twin is the way to go, because you have endless possibilities of creating simulations and then seeing what results you get, and it is you can keep on changing your input, and for that you get a predictable output. In case of Gen AI, that will not be the case, because you have a probabilistic thing, because every time you change, you get into it's like a metaverse where you get into a different world altogether, and it cannot be repeated every time. Every time the reality, the timeline changes, like what you see in Avengers. So here, I think digital twin is the way to go.
So we have a couple of questions here. Mati says, where are we with AI and quantum computing?
Jayanta, you want to take it up?
Yeah. So yes, of course, in AI, we have a lot of use cases, what we are doing internally, as well as generating AI accelerator, and also offering customer solutions in AI. To my knowledge, today in quantum computing, if you see from ALTEN side, we have not been doing a lot in quantum computing, but of course, in the future, we may be working on quantum computing, but not today.
Okay, we have questions lined up. So Enrique says, do you have some insights regarding testing of AI-driven transformation in aero and automotive?
So I'll answer for automotive. For automotive, we have a full-fledged framework where you start with the requirement. It automatically generates the test cases, test scripts, and in fact, it can be integrated with the robo framework, including robotic arm, wherever it's needed to test the setup or create any inputs and those kind of things. So that way, and these are deployed with global OEMs as well, and efficiency improvement is seen close to 30 to 40%, and since they can run round the clock, so the productivity and turnaround time of validating the systems, including the improvement of coverage, has been seen and certified by customer as well. So that way, in a validation, definitely AI has taken leap steps, and the results are already seen in terms of turnaround time, improvement of quality, as well as productivity improvement.
Okay.
Yeah, I think same in the aerospace side, the auto code generation, auto test case generation, validation, all these are possible. But at the end, someone has to actually validate the data and ensure that it is right. So you still need one layer of human intervention.
Okay. Funil says, what kind of skills and tools shall engineers equip with to be aligned with this AI revolution in aero and automotive industries?
So what I would say is AI is a must for all engineers, but first understand the basics of your domain or your fundamental engineering branch or the branch in a way, and then see what AI tools, whether it could be as simple as Python scripting with AI models that can be deployed For example, a mechanical engineer can know how to convert a 2D to 3D drawing using which model and how do I write a Python script to do that, or how some of the AI features in the design tool that I can use to improve my productivity. So like this kind of a thing would help them to be more relevant with the industry and also more value add to the companies that they are working for. But everybody should at least have their own domain knowledge, their own branch of engineering that they have studied, get those basics right, and then understand the AI tools and some level of Python scripting that you can bring on top to bring in the automation and AI into your area of work.
Okay. Mukunda asks, what regulators can be adapted to AI-driven systems when dealing with safety-critical content apart from human in the loop? Oh.
Jayanta, you want to take
Jayanta?
it?
So basically today lots of tools are available for shortening the life cycle of product development, software verification, validation. See, this is I think the easiest part to automate and easiest part where AI can play a big role in verification, validation, and of course after that you can attack the coding aspect of it. So human intervention, I don't think it can go away easily, because the regulators will definitely not agree, and I also think people will not be comfortable sitting in an aircraft, for which the software is developed by the developer, who actually has given everything to the automation without really intervening from the human side. So I think human aspects will still be there, at least in the foreseeable future. And without that, the regulators will not accept any, unless it is a very, very low level of criticality. Like for example, in aircraft, if you are, it is a audio system or infotainment, you really don't care about the safety aspect of it. So those things are fine, but as soon as it deals with the aerodynamics of the aircraft or navigation aspect of it, aircraft landing, autopilot, I mean, human has to be there. You cannot take it away.
So I think we have 3 minutes left. Let's take one more. So Balakrishnan asks, as we need to qualify tools used in aerospace software per DO 330 standards, how will tool qualification be performed for AI tools, given that the DO 330 is designed for deterministic software? So Jayanta, that's for you.
Yeah, I know this DO 330 was a new standard which came up not very long ago, not in comparison to DO 178P and all. So this is a standard today which we have for tool qualification for any of the tools that is used for in automating any standard process. But for AI today, you don't have any such tool qualification standard. But I think with time there will be such standards. Not today; it is not available. But again, as I said, it cannot be used probably at the higher level of criticality. At lower level of criticality, you may be able to use, but we don't have anything available today from the regulatory authority. No such standards available.
Maybe one last one. What is the roadmap to deal with data privacy and security while integrating with AI? So this is from Mohammed Ismail.
So not just the roadmap, there are already, as I said, regulations in place, whether it's GDPR or the European AI Act. So that specifically addresses the Data Privacy Act. Since ALTEN is involved in a lot of data annotation as well as data information interpretation in a way of the AI-led models, which globally as well. Whenever we get data, that's why we get mass data, taking out all the private information out the data for processing or for annotation and everything. So all these regulations are already in place, and companies are complying with it, and that way there is a good data protection already in place in practice as well. Yeah.
Thank you. So Lokesh, Purushottam, Shankar, Mukunda will answer to you at a later point in time. So before we wrap up, so I would like to thank Shruti Bojama and team from our marketing department, because a lot of work happens behind the scenes, conceptualizing, aligning stakeholders, promoting the event, and ensuring flawless execution. So this has been done exceptionally well. So thank you for making today's webinar a success. But I would like to, we would like to really value your feedback, not as a formality, but to help us shape more meaningful sessions like this. So in the chat, in one word, what stood out most for you today? If you can, leave it to us, it will really help us. So until signing off, until next time. Thank you, Pramod. Thank you, Jayanta. Thank you, everyone.
Thank you, Rakesh.
Thank
Enjoyed
you,
the
Rakesh.
conversation.
Thanks, everyone.
Thanks, Jayanta.
Thank you.
Bye.
Bye.
Thank you all.
Thanks, everyone.
Bye.
Bye-bye.
Thank you all.